Hello dear students, in this video I'll continue with the 8th unit linear programming problem. Here I'll solve the questions from question number 6, subdivision 2nd to 5 of Check Your Progress 8.6 from the CBSE Handbook. All these problems should be solved using the graphical method. So here we have the 6th question, solve the following linear programming problem graphically. In my previous videos, I have explained about mathematical formulation of a linear programming problem, then how to solve a linear programming problem when the feasible region is bounded and when the feasible region is unbounded. So let us remember all those and let us solve these questions. The question says minimize z is equal to 5x minus 2y subject to the constraints 2x plus 3y, it is greater than or equal to 1 and x greater than or equal to 0. Y greater than or equal to 0. So here when we see the constraint itself, we can see that the region will be unbounded. Now we will see how we can solve this. So first let us draw a graph. Let us take a graph, then draw the axis OX, OY and choose an appropriate scale. Now first we will draw the line corresponding to 2x plus 3y equal to 1. So let us mark this as 1. So the line corresponding to first equation, when x is 0, y is 1 by 3 and when y is 0, x is half. So 0 comma 1 by 3 is somewhere here. Now we have to plot the points 0 comma 1 by 3 and half comma 0 on the graph and draw a line joining these 2 points. So the line will give this equation 2x plus 3y equal to 1. So this is 0 comma 1 by 3 and then half comma 0 is the next point. This is half comma 0. So if we draw a line joining these 2 points, then we will get the line corresponding to the first equation. So this is the first one. Now since this is the only constraint which is given and we have the non-negative constraints, here x greater than or equal to 0, it is this part. This is x greater than or equal to 0 and this is y greater than or equal to 0. And now the region corresponding to 2x plus 3y greater than or equal to 1, if we substitute the coordinates of the origin 0 comma 0, then we can see that 0 is not more than 1, which means origin does not lie in this equality, in this inequality. So the region corresponding to 2x plus 3y greater than or equal to 1, it is this part. So the feasible region is this region. So this is the feasible region. So here we can see that the feasible region is unbounded. And we have 2 corner points A and B. Let us mark these 2 corner points as A and B. So this is A and this is the corner point B. Now let us find the value of Z at these corner points. So here we have the corner point. Let us draw a table like this. And Z is equal to 5x minus 2y. So at corner point A, half comma 0, Z is 5 by 2. And at corner point B, 0 comma 1 by 3. We have to substitute x as 0 and y as 1 by 3. So we get minus 2 by 3. So this is the minimum value. Now when the feasible region is unbounded and when the objective function is to minimize z, then we have to find the half plane corresponding to z less than the minimum value. So we have to find the half plane corresponding to 5x minus 2y less than minus 2 by 3. So for that what we can do, first let us draw the line corresponding to 5x minus 2y equal to minus 2 by 3. So this is for this line. All these can be done. It can be done in the rough. Here we have x and y. When x is 0, y is 1 by 3, and when y is 0, x is minus 2 by 15. So we have 0 comma 1 by 3. So this is the point 0 comma 1 by 3. If this is 0 comma 1 by 3, then we have minus 2 by 15 comma 0. It is somewhere here, minus 2 by 15 comma 0. Now let us draw a straight line joining these 2 points so that we will get this line 5x minus 2y equal to minus 2 by 3. So this is the line corresponding to 5x minus 2y equal to minus 2 by 3. And now if we see this 5x minus 2y less than minus 2 by 3, if we substitute the origin and check, that is when x is 0, y is 0. 0 is not less than minus 2 by 3. It means the origin, it does not lie in this half plane. So the region corresponding to 5x minus 2y less than minus 2 by 3, it is this part. So the region corresponding to 5x minus 2y less than minus 2 by 3, it is this part. Here we can see that the half plane corresponding to 5x minus 2y less than minus 2 by 3, it passes through the corner point and crosses the feasible region, which means this linear programming problem does not have an optimal solution. So no values of x and y will minimize z. So here is the result. The inequality 5x minus 2y less than minus 2 by 3 passes through the corner point B 0 comma 1 by 3 but lies in the feasible region. But this line lies in the feasible region. Hence the given LPP has no solution and z cannot be minimized for any values of x and y. So hence this linear programming problem does not have a solution. Now moving on to the next question. Minimize z is equal to minus x plus 2y subject to the constraints minus x plus 3y less than or equal to 10, x plus y less than or equal to 6, x minus y less than or equal to 2, and the non-negative constraints x greater than or equal to 0 and y greater than or equal to 0. So on a graph sheet, draw the x-axis, y-axis and plot the point and choose an appropriate scale. Now let us draw each of these lines. So let us mark this as 1, this is 2 and this is 3. Now let us take the first one. The first line is minus x plus 3y equal to 10. So when x is 0, y is 10 by 3 and when y is 0, x is minus 10. So 10 by 3 is 3.33. So 0 comma 3.33, it is somewhere here. This is 0 comma 10 by 3 and minus 10 comma 0. It is this point. So if we draw a line joining these 2 points 0 comma 10 by 3 and minus 10 comma 0, we will get the line minus x plus 3y equal to 10. So this is the line minus x plus 3y equal to 10. And then we have the next line x plus y equal to 6. The second one, when x is 0, y is 6 and when y is 0, x is 6. So this is 0 comma 6 and this is 6 comma 0. If we draw a straight line joining these 2 points, we will get the second line. And then we have the third line x minus y equal to 2. When x is 0, y is minus 2 and when y is 0, x is 2. So this is 0 comma minus 2 and this is 2 comma 0. If we draw a straight line joining these 2 points, we will get x minus y equal to 2. So this is the third. And now let us find the feasible region. The first one, minus x plus 3y less than or equal to 10. If we substitute the coordinates for the origin 0 comma 0, 0 is less than 10. So the region corresponding to minus x plus 3y less than or equal to 10, it is this part. And then next we have x plus y less than or equal to 6. If we substitute the coordinates of the origin 0 comma 0, when x is 0, y is 0, 0 is less than 6. So the region corresponding to x plus y less than or equal to 6, it is this part. And then we have the next one, x minus y less than or equal to 2. Again the origin 0 comma 0, it lies because 0 less than 2. So this origin, it lies in this inequality. So the region corresponding to x minus y less than or equal to 2, it is this part. And then we have x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So the feasible region is the region which is common to all these inequalities. So this is the feasible region. Now here we don't have a problem because here the feasible region is bounded. If the feasible region is bounded, then the maximum minimum value of z occurs at the corner points. So here we have minimize z is equal to minus x plus 2y. Now we need to find the corner points. So the various corner points are, first one is the origin, and then we have this corner point. Let us mark this as A. So this is A 2 comma 0, and then let us mark this as B. This is C, and then we have D 0 comma 10 by 3. Now let us try to find the coordinates for B. If we draw this on a graph sheet, we will be able to find the coordinates directly. If you are not able to find the coordinates, then we can solve equations 2 and 3. So when we solve equations 2 and 3, we will get the coordinates for B. All these can be done in the rough. If we solve these two equations, we can see that we get x is equal to 4 and y is equal to 2. So the coordinates for B is 4 comma 2. Even here it is coming slightly 4 comma 2. And then to find the coordinates of C, here again if we draw it on a graph sheet, we can see that the coordinates for C is 2 comma 4. Or if we want to check also, we can solve the equations 1 and 2. So for C, we have to solve the equations 1 and 2. So 1 is minus x plus 3y equal to 10 and 2 is x plus y equal to 6. If we add these two, we get 4y equal to 16. So y is 4 and x is 6 minus 4, which is 2. So the coordinates for C is 2 comma 4. And now let us draw the table and find the minimum value of z. Here we have the corner point, and here we have z is equal to minus x plus 2y. So the various corner points are 0 comma 0, then A 2 comma 0, then B 4 comma 2, then C 2 comma 4, and then D 0 comma 10 by 3. Now let us find the value of z. When we substitute x as 0, y as 0, we get z as 0. Then for A 2 comma 0, when we substitute x as 0, x as 2 and y as 0, we get z as minus 2. Then for B 4 comma 2, when we substitute x as 4 and y as 2, we get minus 4 plus 4, it is 0. Then when we substitute 2 comma 4, that is x as 2 and y as 4, we get minus 2 plus 8, it is 6. Then when we substitute x as 0 and y as 10 by 3, we get 20 by 3. So this is the minimum value. So we can see that the minimum value of z occurs at the corner point a 2 comma 0 and the optimal solution is x is equal to 2, y is equal to 0 and the optimal value of z is minus 2. So the corner point a 2 comma 0 minimizes z, hence the optimal minimum value of z is equal to minus 2 when x is 2 and y is 0. So this is the result. Next question, maximize z is equal to minus x plus 2y subject to the constraints minus 0.5x plus y less than or equal to 2, x minus y less than or equal to minus 1 and x greater than or equal to 0, y greater than or equal to 0. So let us solve this. So let us draw the axis yx oy and choose appropriate scale. Now let us draw the lines corresponding to these. Let's take this as 1 and 2. So for the first one, to draw the line corresponding to minus 0.5x plus y equal to 2, when x is 0, y is 2. Minus 0.5x plus y equal to 2. When x is 0, y is 2. Then when y is 0, x is 2 by minus 0.5, which is minus 4. So if we plot the point 0, 2 and minus 4, 0 and join these 2 points, we will get this line. So this is 0, 2 and here we have minus 4, 0. Now let us draw a line joining these 2 points. So this is the first equation. Then moving on to the second one. Then for the second one, x minus y equal to minus 1. When x is 0, y is 1 and when y is 0, x is minus 1. So this is 0, 1 and this is minus 1, 0. If we draw a line joining these 2 points, we will get the second line. So this is the line minus 0.5x plus 2y equal to 2 and this is the line x minus y equal to minus 1. Now let us find the feasible region. Now if we take the origin and take the first inequality minus 0.5x plus y less than or equal to 2, if we substitute x as 0, y as 0, then 0 is less than 2, which means the origin lies in this region. So the region corresponding to the first inequality is, it is this region, this part. And then for x minus y less than or equal to minus 1, if we take the origin and take the coordinates 0, 0, 0 is not less than minus 1. So the region corresponding to the second inequality is, it is this part. So this is the region corresponding to the second inequality. And then we have the non-negative constraints. X greater than or equal to 0 and y greater than or equal to 0, it refers to the first quadrant. So the feasible region or the region which satisfies all the constraints, it is this part. So this is the feasible region. Now let us mark the corner points. So this is one corner point A 0, 1 and then we have B and then next corner point is C 0, 2. So we have these 3 corner points. Now to find the coordinates for B, let us solve these two equations. So if we take 0.5x plus y equal to 2 and x minus y equal to minus 1, if we add these two, we get 0.5x is equal to 1 or x is equal to 2. Now when x is 2, if we substitute in the second equation x minus y equal to minus 1, we get y is equal to 3. So the coordinates for B is 2, 3. So if we draw this on a proper graph sheet, then we can get the coordinates very easily. So the three corner points are A 0, 1, B 2, 3 and C 0, 2. Now let us find the value of Z in each of these corner points. Z is minus x plus 2y. So we have A 0, 1, B 2, 3 and C 0, 2. So for the corner point A 0, 1, when we substitute x as 0 and y as 1, we get Z as 2. Then for corner point 2, 3, when we substitute x as 2 and y as 3, we get 6 minus 2, 4. Then when we substitute 0, 2, that is x as 0 and y as 2, we get again Z as 4. So here we can see that the two corner points B and C have same value for Z, which is 4. So both these are maximum values. So here we can see that the corner point B 2, 3 and the corner point C 0, 2. Here both these points optimizes the objective function because we get the maximum value of Z for both the points B and C. It means all points lying on this line segment BC, it will maximize Z. So here we have the result. The value of Z at points B and C are same. Hence the maximum value of Z equal to 4 occurs at the corner points B 2, 3 and C 0, 2, and all points lying on the line segment BC will maximize the objective function. As a result, we have the given LPP has infinite optimal solutions. So the given linear programming problem has got infinite solutions which occur on this line segment BC that will maximize Z equal to minus x plus 2y. Moving on to the last question, maximize Z is equal to 5x plus 4y subject to the constraints x minus 2y less than or equal to 1, x plus 2y less than or equal to 6, x minus y greater than or equal to 3 and x greater than or equal to 0, y greater than or equal to 0. Now let us solve this graphically using corner point method. So on a graph sheet, draw the axis and choose an appropriate scale. Now let us mark these as 1, 2 and 3. So for the first one, let us draw the first line. When x is 0, y is minus half. When y is 0, x is 1. So this is 0, minus half and this point is 1, 0. So let us draw a line segment joining these 2 points. So this is the first line. Moving on to the next line, x plus 2y less than or equal to 6. So the second line, when x is 0, y is 6 by 2, 3 and when y is 0, x is 6. So this is 0, 3 and this is 6, 0. If we draw a straight line joining these 2 points, we will get the second line. So this is the second line. Moving on to the third line, x minus y equal to 3. When x is 0, y is minus 3 and when y is 0, x is 3. So this is 0, minus 3 and here is 3, 0. So if we draw a straight line joining these 2 points, we will get the line x minus y equal to 3. So this is the third line. Now let us try to find the feasible region. The first inequality is x minus 2y less than or equal to 1. Now let us see whether the origin lies in this. When we substitute x as 0 and y as 0, we get 0 less than 1, which is true. So for the first inequality, the region corresponding to the first one is this part. And then the second one is x plus 2y less than or equal to 6. Again, when we substitute x as 0, y as 0, the origin, it is less than 6. So the region corresponding to the second inequality is, it is this part. And then we have the third inequality. If we take the origin 0, 0 when x is 0, y is 0, 0 is not greater than 3, 0 is less than 3. So the region corresponding to x minus y greater than or equal to 3, it is this part. So here we can see that there is no region which is common to these 3 inequalities itself. So there is no solution at all. And if we take the non-negative constraints also, x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So there is no region which satisfies all these constraints, or there is no point which satisfies all these constraints. So as a result, this linear programming problem, it does not have a solution. No values of x and y will satisfy all the constraints. So this problem does not have a feasible solution. On plotting the graph, we can see that there is no possible feasible region for the given constraints. Hence, the given LPP has no solution and Z cannot be maximized. So this is the result for the fifth linear programming problem. I hope this video was useful for you. The syllabus for the second term is completed with this topic. I wish all the students all the best. I hope you all will do well in the exams. I have made videos on all the topics of term 2. The links are available in the description. Thank you for watching.